Okay, a while back I promised to talk about finding the square root of 47 and 48. So let's get started on that. So how to find the square root of numbers like 47 and 48. Now these numbers are just below the perfect square 49. So let's first solve the square root for 48. Now straight from the beginning I've assigned some numerical values to some variables. Very similar to what I talked about in my previous videos. So if you haven't looked at those videos, you can just look at them on my YouTube channel. If you're watching this video, it should say Get It's Realist somewhere near the video. It's a little link, just click on it, it'll take you to all my videos, okay? Okay, so here are the variables and here are the numerical values. Assigned to each of these variables R, N, D, F, and S. So let's look, how do we get these numbers? Okay, well 48 is the number we're trying to solve, square root, get the square root for this number, right? So it's obvious where that came from. Okay, how do we get N equals 12? Alright. We simply take the number we're trying to find the square root for, which is 48, and we subtract 36. Now where does 36 come from? That should be pretty obvious, but it's the perfect square below 48, right? The perfect square below 48. Let's look at the spreadsheet real quick. So here we are. We're trying to get the square root for this number here, 48, correct? The perfect square below that is over here, 36. Yeah? Okay? So we're trying to get 48, and the perfect square below it is 36. Okay? So that's where 36 came from. What is 48 minus 36? It's 12. So that's how N is assigned the numerical value of 12. Okay, let's look at D. How do we get 13? We simply take the perfect square above 48, which is 49, and we subtract the perfect square below it, 36. So D is equal to 13. Okay, so that's how we get D equal to 13 here. Okay, now, how do we get F equals 15 up here? The way we do this is we take the perfect square that's above 48, which is 49, and the perfect square above 49, which is 64. Okay, so both the perfect squares above 48. Take the larger of the two, 64, and subtract the smaller of the two. Okay? Okay, the perfect square above 48 is 49, right? 7 times 7 is 49, and 8 times 8 is 64, right? 7 times 7, 8 times 8. Correct? Those are perfect squares. So F is equal to 64 minus 49. And we get 15. So that's how F is equal to 15. If you're not sure what I just said, pause the video, go back, play it again. Okay, I'll show you the spreadsheet real quick here. Right? We're here trying to get the perfect number for the square root for this number 48. Okay? The perfect square above it is 49. And the perfect square above that one is 64. Right? So the two perfect squares above 48 are 49 and 64. Okay? So that's how F is equal to 15. Okay? And S equal to 6 is pretty obvious. That's the square root of 36, which is the perfect square below 48. Alright, so now you know how you got all these numbers. How you got the numbers, these numerical values assigned to these variables. Again, if you need to stop the video or rewind it a little bit, especially, particularly for the variable F, I know that F can be a little confusing, go back and listen to it again, okay? And you can pause it when I'm at the point where I showed you the spreadsheet. The visual sometimes really helps people. Okay, if you looked at my previous videos, this equation, this expression is probably looking familiar. Okay, so we're just going to substitute the numbers and put them into this equation, right? R is equal to 48, so square root of 48 equals N over D, which is 12 over 13. Okay, plus 1 over D times F. D times F is 13 times 5, plus S, which is simply 6. The result, ignoring the to the power of 2 here, we get this number right here. This expression yields this number. Okay? When we square it, which is the little superscript 2, to the power of 2 or squared is the same thing. The result, 48.quadruple02. That's pretty accurate, guys. Really nice. Now, what you're going to notice if you that this exact approach that I just showed you here will also work for numbers like 63, because just like 48 is just below the perfect square 49, 63 is just below the perfect square 64. It also work for numbers like 24, 15, 80, okay, let's see, 99, right? Those are all numbers that are just one natural number below perfect squares, right? 24 is just below 25, which is a perfect square, okay? 35, which is just below 36, it'll work for that. Okay, obviously 48, which is just below 49, we just did that. Okay, 63, which is just one number below 64, and so on and so forth, guys, all the way up as high as you want to go. Okay, so that's how you get the square root of 48 and other numbers that I just mentioned. Okay, let's look at 47, because I promised I'd show you that too. 47 is a little bit harder, but pretty much the same thing with a small change in how we derive at getting the value for f. Okay, we are looking for the square root of 47, so we're just going to assign that to r. Okay, and a lot of algebra, that would also be x. Sometimes you see people just, x. Solving for x. But I'm using r instead. I use r because this really means radicand. Look that up, Google it, whatever you want, and you'll find out what radicand really means. So that's why I use r. Okay? How do we get n equals 11? Very similar to what we did in the previous example. 47 minus 36. Again, 36 is the perfect square below 47. So that's how we're getting n equals 11. Okay? How do we get d equals 13? Same thing we did up here. Okay, I'm not really going to go through it again. Straightforward. 49 minus 36 equals 13. Okay. Okay, I'm going to skip over f for a second, just talk about s. Same thing we did above, right? Same thing there. How do we get s equals 6? It's the square root of 36. Again, the perfect square below 47 is 36. And the square root of 36 is 6. 6 times 6 equals 36. So that's how s is equal to 6. Okay, let's talk about f, because this is really the most important value for the equation. Now, you'll notice when I talked about before, when we were looking for the square root of 48, f was just equal to 64 minus 49. Okay? And this time what I did is, I'm first going to show you a little bit of an algebraic expression, okay, and then talk about it. So there it is. F for 47, f is equal to s3 minus s2 minus s minus 1. Okay, we're already looked at 64 minus 49. So s3 in this case is equal to 64. s2 is equal to 49. Okay, s, which we talked about already, is equal to 6. So it's just a very simple algebraic expression, right? So all we're doing is the same thing we did for 48, is 64 minus 49, which we know is equal to 15, right? Minus 6, which is the perfect square for 6, which is the square root for 36. And finally, subtract 1. Okay, so for those of you who are following along, these are all pretty obvious. So you might be asking, where did you get 1? One is a discovery. In mathematics, we do things sometimes by trial and error. We look for patterns. Okay. Once is simply a discovery, guys. I took the time to try out some different approaches to see what would work, and subtracting 1 works every time. Okay. So that's how we get f equals 8. 64 minus 49 minus 6 minus 1 equals 8. Okay? And if you're wondering, will this work for numbers like 23, which would be 2 numbers below the perfect square of 25? Yeah, it works. Same thing we talked about before. Instead of being 1 number below a perfect square, we're talking about 2 numbers below a perfect square. So this will work for 23. It'll work for 14. Okay, 14, 23, obviously 34. We're looking at 47 right now, which is 2 numbers below 49. Okay, it'll work for 62. Okay, 81, 8 will work for 79. Okay, it'll work for 98. Okay, and so on and so forth. It'll work for what? I guess that's 119. And it'll also work for 142. And so on and so forth, as far up as we want to go. Okay, so now you know how the numbers have been derived. Same exact algebraic expressions we have been using all along. So let's take a look. Square root of 47, which is r, and over d is 11 over 13, plus 1 over 13 times 8, plus 6. We get this number right here. Okay, when we square it, or to the power of 2, or multiply the number by itself, the result is 47,0015. Again, very accurate, works really well. Okay, so that's it, guys. I hope you got something out of that. That is how you get the square root of 47 and 48. Okay, which is right here. Okay. And for those of you who are paying attention to this video and you're pausing the video, you'll notice that F, it just happens to be in the F column, okay, in the spreadsheet. But basically F, meaning, you know, this F right here, right? Factor or whatever. You'll notice that here's 8. All right, that's how we were just talking about this number 8. Okay, 47. F is 8. Here's 11, right? It's really just an iterator. Right, 1 through 12. It's an iterator, it's 11. It's derived by taking 47, subtracting 36, which we already talked about. Okay? Another way you can do this, for those who really want to follow this, the first natural number above 36 is 37. Okay? 13 is pretty simple. It's 49 minus 36. That's how we get 13 for F. How do we get 7? For 38, for the variable F, it's simple. 13 minus 6 gives us 7. What is 6? The square root of 36. Okay? 13 minus 6 gives us the 7. Okay. How do we get 5? I'm working on that right now, guys. It's coming soon, I hope. We're going to get a breakthrough on that. Right now, I'm just, for 5, for 39, I just simply typed in the number there. It worked out really well. I got some new things coming up. Okay? You can look at that equation up there if you want to really think about it. Okay? You'll notice up in this top of this video here, top of this spreadsheet, I got 3 different equations, and they're working really well. Depending on where you're at within the data set, one of these 3 equations will be used. Okay? The data set meaning natural numbers that lie between 2 perfect squares. In this case, 37 through 48. Okay? Look at these square roots, guys. Look at these squares. Sorry. How accurate they are. Look at this. They're all very accurate. Look at my AVG talking to me here. Go away. Alright, so I'm going to get back to you about some other things. We'll once I get a breakthrough on how 5 is derived. Remember, we already talked about 42 in another video. Okay, so I'll get back to you on that, and once I get a breakthrough. Okay, but what I want to talk about right now is, you'll notice that 48 for the value f is 2 greater than the 13. Right? So the last natural number in the data set, in this case 48, for the value f will always be 2 greater than the value for the first number in the data set, 37. Okay. I just talked about how to get 7, which is 13 minus 6 gives us 7. So for 47, I showed you a different method in the video, but if you really want to do it another way is, you'll notice that 8 is just 1 more than 7. Okay, that's another way to do it. Also, if you're really paying attention, what you're going to notice is, going up to 50, it's for the value f is exactly the same as the value of 48, isn't it? Not only that, for 51, f is the same value for 47. Right? You see that? 8, 15, then we just invert it and descend. 15, 8. Now usually, almost always, but not always, but almost always, the third number will be the same as the third to the last number in the previous data set. Very, very common. In this case it's not, but almost always it is. Okay. So I'm going to work on a breakthrough for 39 and how to derive 5. Okay, haven't quite gotten there yet. Got some things that look really good, but not 100% of the time, so we got to work out some things. So that's it for now, guys. Once I get a breakthrough on 39 and the value of f for 39, and it can be applied to other data sets, then I'll talk about that too. Okay, so appreciate you taking the time to watch my videos. Okay, enjoy it. Some serious breakthroughs on square root.